In this video, I'm going to be evaluating the double integral you see here on the screen. We have a function, 2x plus 6 cosine y cubed. Now, we have to integrate this first with respect to y because the dy comes first. The integral associated with that is going to be the inner integral, and the outer integral corresponds with x. So the thing is that for this function, integrating with respect to y is impossible because of the cosine y cubed term. So the way we do this is we're going to switch the order of integration so that dx comes first. How do we do that? We have to draw a picture. Now, this is a double integral. Our two variables are x and y, so this is a double integral in the xy plane. So I'm going to draw the xy plane. And now, the values of y go from square root x to 1. So y equals square root x will be the lower bounding curve. So I'm going to draw that. So this is y equals square root x. And the upper bounding curve is going to be y equals 1. So y equals 1. Let's see. So now the values of x go from 0 to 1. So from here to here, where the two curves intersect. So our domain of integration is going to be this, this area right here. Now, because dy comes first, this domain is being integrated over vertically, so it's more accurate to shade it like this. So from the lower bounding curve to the upper bounding curve, the domain is being integrated over like so. Our goal now is to make it so that it's being integrated over horizontally, so that, in other words, so that dx comes first. So x and y, and I'm going to redraw the domain so that it looks like this, and our goal is to make it so that it's being integrated over horizontally. So this is we have to create new bounding curves that are so the lower bounding curve is going to be this right here. So that's x equals 0. I should use different colors, right? So the lower bounding curve of this region is this this curve here, and that is x equals 0. The upper bounding curve is going to be this curve right here, which is y equals square root x. So if we solve that equation for x, that's going to be x equals y squared. And now, so let me write this out. So we're going to have the same function, 2x plus 6 cosine y cubed, and now dx dy. So for x, the lower bound is going to be 0, and the upper bound is going to be y squared. Now, to find the limits of in y, we have to project this domain onto the y-axis. So it's going to be so if you just take the projection of this domain onto the y-axis, you get this yellow bar that I'm drawing right here. Now the minimum value is going to be 0, and the upper value is going to be 1. So these are going to be the new limits. All right, and now that we switch the limits of integration, we can proceed. So we integrate this function with respect to x. So we leave the outer integral alone, and now we take the antiderivative of what's inside. So this is going to be x squared plus 6x cosine y cubed And then this is evaluated from 0 to y squared dy. All right, and let's see. So now we plug in. So plugging in 0 for x makes the whole thing 0, right? So the only contributing terms are going to be when we plug in y squared. So this is going to be integral from 0 to 1, y to the 4th, plus 6 y squared cosine y cubed dy. And now we're going to split up this integral into two. So integral from 0 to 1 y to the 4th dy plus 6 integral from 0 to 1 y squared cosine y cubed dy. Now this first integral we can solve easily. It's going to be the, we bump up the exponent by 1 and divide by that same number. So this is the antiderivative for the first integral. We evaluate it from 0 to 1. And now for the second integral, we have to use a u substitution. So I'm going to set u equals y cubed. And what is du going to be? Du is going to be 3y squared dy. So let's see. So this is going to be 2 integral and then cosine u du. Now to find the new limits of integration, we have to plug in 0 and 1 into this formula here. So when y is 0, 0 cubed is going to be 0. So that's the new lower limit. And if we plug in 1 for y, 1 cubed is also 1. So the limits happen to be the same for the new integral in terms of u. But anyway, so now we can evaluate this. So this first integral, if it comes out to 1/5, and then plus 2 sine u. This is the antiderivative of cosine, evaluated from 0 to 1. Plugging in 0 doesn't. Plugging in 0 gives us 0 because that's what sine 0 is. So what we have is 1/5 plus 2 sine 1.